So today we have an interesting geometrical problem. The given data is very simple, there is nothing to be explained in that. All you have to do is find the radius of this circle when the length of this line segments are given, which are arranged in this specific pattern and in a specific way. So let us see the solution. How can we solve for this? So first of all, the most basic thing we can notice over here is that these line segments are meeting with each other at 90 degree. So first of all, let us utilize that. So what I'm going to do is look over here. So what I will do is extend this particular line as a straight line and this particular line as a straight line. So they will meet at this particular point. Now as I told you, a straight line. So by linear pi we have this as 90. So this is also equals to 90 degree. Over here also this is 90. So this is also going to be 90 degree. Now look, in this particular quadrilateral we have three of its angle 90. This is 90, this is 90, this is 90. So by angle sum property we have that yes, the fourth angle is also 90. Now a quadrilateral, all the four angles are 90 degree and adjacent sides are not equal, they are unequal. So it forms a rectangle. So according to the property of rectangle, opposite sides are equal. So this side is 2, so this side is going to have a length that is equals to 2. This side is 1, so this side is also going to have a length that is equals to 1. Now this complete line segment has a length that is 2 plus 2, that is equals to 4. Okay, now what I will do is draw a straight line from this that is perpendicular to this particular line segment. So over here 90 degree. Now look, in this biggest quadrilateral that is formed over here, the three angles are 90, that is this, that and this one. So three angles are 90 degree. So by angle sum property, fourth angle is also 90, and as the adjacent sides are not equal, so it forms a rectangle, and according to the property of rectangle, opposite sides are equal. So that top side is 2 plus 2, that is 4. So this base is also going to have a length that is equals to 4. This complete side is 3. So this complete side, that is from this particular point to this particular point, will have a length that is equals to 3. Okay. Now this complete length is 3. This much part is already equals to 1. So the remaining part, that is from this particular point to over here, is going to have a length that is 2. Now again look carefully, from here to here we have a length that is equals to 3. And this much length is already equals to 2. So the remaining length, that is from this point to this particular point, is going to have a length that is longer minus the shorter, that is 3 minus 2, 1. So that was the only required thing over here. So I'm just removing all these things that is not needed over here. And this particular line segment was having a length that is equals to 1. Now in the third step, I will draw a line segment from this particular point to this particular point, and this is 90 degree because of the linear pair. Now we have a right angle triangle, the base is 4, the side is 1, so by Pythagoras theorem we have the hypotenuse as 4 square 16 plus 1, that is 17, so square root of 17 is the hypotenuse. Okay, now in the fourth step I will draw a line segment from that particular point to this particular point. Let it be clear, yes, from that corner to this corner. That angle is already 90, let this angle be equals to theta. So now look carefully, in this particular triangle, that is triangle A, B and C. In this diagram, this triangle ABC is there. I'm just taking it out of the diagram. So this is AB, BC and AC. AC length we do not have, so let it be equals to in variable K. So AC has a length, first of all let us name it. So A over there, B over here, C over here. AC is having a length that is equals to K. AB is having a length that is 3. BC is having a, first of all let it be clear here, BC is having a length that is square root of 17, and this angle B is completely, so 90 degree plus theta. Now what I will do is apply the cosine rule in this particular triangle so as to get the value of K. So first of all, what is the cosine rule? So if we have a triangle like this way, take any of its angle, let this angle be angle A, the sides are A, B and C, and cos of that particular angle, that is cos of A, is equals to squares of the adjacents added together. So adjacent to angle A are A and B, so they are squares added together, so A square plus B square minus the square of opposite, so opposite to angle A is C, so minus C square upon 2 times the product of adjacent, so 2 times A times B. Now this is the value of cos of angle in any triangle, so I'm going to apply this cosine rule over here. So I'm taking my angle as 90 plus theta, so cos of 90 plus theta is equals to squares of the adjacents added together. Adjacent to this angle are 3 and square root of 17. So 3 square 9, square root of 17 the whole square is 17. So 9 plus 17 is 26, minus the opposite square, so minus k square upon 2 times the product of adjacents. So 2 times 3 times square root of 17, that is 6 times square root of 17. So 6 times square root of 7. Now look carefully, cos of 90 plus theta has a value that is negative sin theta because of the trigonometric rule. Cos of 90 plus theta is negative sin, and it's easy to prove that yes, cos of 90 plus theta is negative sin theta. Recall the identity that cos of A plus B is cos A cos B minus sin A sin B, and just plug in the values of a as 90 and b as theta, and you will reach that yes, cos of 90 plus theta is negative sine theta. Now sine theta is having an actual value. Look in this particular right angle triangle. This right angle triangle encloses this angle theta. This is right angle triangle and all the three sides are given. So we can easily find the value of sine of theta, that is sine of theta in a right angle triangle is opposite upon the hypotenuse. Opposite to angle theta is 1, hypotenuse is square root of 17. So in that right angle triangle we have the value of sine of theta, that is 1 upon square root of 17, and as this negative sign is there, so negative 1 upon square root of 17, and that is 26 minus k square upon 6 times square root of 17. Square root of 17, square root of 17 got cancelled out. I can do the cross multiplication and simplification so as to get that k square is equals to 32. Taking square root on both the sides and simplifying gives me that k is equals to 4 times square root of 2. So this is the value of k. Now look carefully, k is over here from A to C. This is the center of the circle, let it be point Q. From A to Q I will join, and from Q to C I will join. AQ and QC ultimately forms the radius. So let the radius be equals to r, and that is also the radius, so it is also going to have length r. Let this angle over there be equals to alpha, and here it is 90 plus theta. Just take this complete angle as beta. Now there is a relation between this angle alpha and beta, and look carefully that yes, the chord AC is subtending alpha at the center. So keeping that in the mind, let us see the theorem. So if there is a circle, we have a chord AB, and that is subtending an angle at the center, let it be equals to alpha only, and that same chord is subtending an angle in the minus segment as beta, so let it be over there beta. So there is a relation between alpha and beta, so let me show you what it is. So I'm just removing this is the center Q. So from here to here I join a line, let this point be equals to r. So what I can observe is that QA, QR and QB, these three are the radius, so they are going to have a length that is equals to r, means they are equal, just the radius. Now this triangle is an isosceles, so their base angles are going to be equal. So this is A, that is A, and similarly this is an isosceles triangle, so this is B, that is B, and by applying the angle sum property this angle becomes 180 minus 2 times A. Applying angle sum property in this particular triangle, and by applying the angle sum property in this particular triangle, this angle becomes 180 minus 2 times B. Now this complete angle over there was considered as alpha, so I have the value of alpha as 180 minus 2 times A plus 180 minus 2 times B, and this complete angle was considered as beta, so we have the value of beta as A plus B. Now simplifying this particular thing, so alpha is equals to 180 plus 180, that is 360, negative 2 taken common, so inside the bracket A plus B we have the value of A plus B, that is beta. So 360 minus 2 times beta is equals to alpha. We can just do a little adjustment so as to get that beta is equals to 360 minus alpha upon 2. I can separate the denominator. So we have this final relation that yes, beta is equals to 180 minus alpha upon 2. So as I told you that there is a relation between these angles alpha and beta, so here it is that beta is equals to 180 minus alpha upon 2. So now what I will do is apply the cosine rule in this particular triangle, and again apply the cosine rule in this particular triangle. Here we have applied it. Now here we have the value of k, that is 4 times square root of 2. So now let us plug in this value of k over here so as to get the value of cos of beta. Now instead of 90 plus theta we have this particular angle as beta, and instead of this variable k now we have found its value, that is going to be equals to 4 times square root of 2. So as all the three sides of this triangle are given, so we can find the value of cos of beta. So cos of beta according to the cosine rule gives me, so squares of the adjacent side together minus the opposite square upon 2 times the product of adjacents. So 3 square 9 plus 17 minus 32 negative 6 upon 6 times square root of 17. So the value of cos of beta is negative 1 upon square root of 17. Okay, this is the value of cos of beta, and we are going to realize it in a moment. Over here look carefully that yes, beta was equals to 180 minus alpha upon 2. I can take cos on both the sides, so cos of beta is equals to cos of 180 minus alpha upon 2, so it gives me negative cos of alpha upon 2. You can just use that trigonometry identity, cos of a plus b is cos a cos b minus sin a sin b, and here it is negative, so cos a cos b plus sin a sin b, so as to get that yes, cos of 180 minus alpha upon 2 is negative cos alpha upon 2. Now look carefully, we have the value of cos of beta over there, that is negative 1 upon square root of 17. So instead of cos beta I will put its value, that is negative 1 upon square root of 17, and that is negative cos of alpha upon 2. So negative to negative got cancelled out. We have the value of cos of alpha upon 2, that is equals to 1 upon square root of 17. Now look in that particular triangle that is containing this k and r. Over here this triangle, The only variable present in this whole triangle is r because we have the value of k, and here is the angle alpha. So as I showed you over here, we have three sides, so we can easily find the value of cos of alpha. And if we have the value of cos of alpha and only one variable present in the triangle, we can just compare this value of cos of alpha with that particular value that we will get. LHS we will compare. So if we have the value of cos of alpha, so we can apply that over here so as to get the value of r. Now look over here, we have the value of cos of alpha upon 2. So we can use the trigonometric rule that cos of 2 times the angle is equals to 2 times cos square same angle minus 1. So cos 2a is equals to 2 times cos square a minus 1. Now in this particular identity, we can replace a with alpha upon 2. So we will get that cos of 2 times alpha upon 2 gives me cos of alpha, and that is 2 times cos square alpha upon 2. Cos alpha upon 2 has a value that is 1 upon square root of 17, and its square becomes 1 upon 17. Minus 1, simplifying this, gives me that cos of alpha has a value that is negative 15 upon 17. So as we have the value of cos of alpha, we can apply the cosine rule in that particular triangle, that is like this way. This, and this. Here's the point A, here's the point B, here's the center Q. This is r, that is here is the length k, and it is 4 times square root of 2, and this particular angle has alpha. So now if I will apply the cosine rule, so cos of alpha has a value that is negative 15 upon 17 that we have just found over there, is equals to squares of the adjacent added together. So r square plus r square 2 times r square minus the opposite square, so minus 32 upon 2 times the product of adjacent, so 2 times r square. Now cross multiplying and simplifying, so negative 30 times r square is equals to 34 times r square minus 32 into 17. Adjusting these terms, so we get that 32 into 17 is equals to 34 r square plus 30 r square, that is 64 times r square, dividing both the sides by 64. So r square is equals to 32 into 17 upon 64. From the table of 32, it goes 1, it goes 2. So here we have the value of r square, that is 17 upon 2. All we need is the value of r, so we can take square root on both the sides so as to get the value of r, that is square root of 17 upon 2, and that's the answer. That radius of this circle is equals to square root of 17 upon 2. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below, and if it's hard to comment, you can email me, or else you can DM me on my Instagram. The links are in the description.